So we're going to begin part 2 here. And in this part, we're going to talk about what can we actually do with these trig ratios and the trig functions on our calculator. And so one of the things that we can do is solve for the sides of right triangles. If we're given enough information, if we're given at least one of the angles and one of the sides, we should be able to solve for any part of it that we want. So we're going to solve for an unknown side. So in this case, we're going to solve for AB. I'm just going to call this X as our unknown, and we'll solve for that. Now, process here is identify the angle that you know. This is going to be the angle you use to label the sides of your triangle. So that's step 1. Identify your angle. Step 2, let's label the sides of the triangle relative to this angle. So obviously we have our hypotenuse, which is always across from the right angle here. And then we have the opposite side over here. And we have the adjacent side right here next to it, right next to our angle. Now, with those 3 things labeled, we need to decide which of the 3 trig functions and trig ratios are going to be best for us to solve this problem. So, toa. So we choose the trig function based on the sides. So we choose the side we know and the side that we want to know. And together, those are going to tell us which trig function and trig ratio we're going to be using. So in this case, we know the opposite and we want to know the adjacent, which tells us to use tangent. Tangent is the only one that includes both of those 2 sides in it, opposite and adjacent. The other ones do not. They involve the hypotenuse somewhere, and yeah, they leave out one of these. So in this problem, we'll be setting up an equation using tangent. Now, for this problem, we have tangent of our angle. So whatever our angle is equal to opposite over adjacent. This is the equation we're going to be writing in order to solve for the unknown adjacent side. Now, for us, the angle that we're working with is a 41-degree angle, so it will be tangent of 41 degrees. That's our angle, is equal to the opposite side, which is 6.1 inches, divided by the adjacent side, which is our unknown x. So here we have a nice equation that we can solve and get x. I know a lot of people are going to be tempted to immediately jump into their calculator and do tangent of 41. We know this is going to be a really long, messy decimal. So let's not do that. Let's wait. We're going to calculate things at the end. This is going to be our preferred method, is to save all of our calculations until the end. But bear in mind, this is just some sort of a decimal. This is just a number. So we're going to kind of keep it in this form for now, but eventually we will get rid of it. We'll calculate with it. So how do we solve for x? Right now, this is actually one of the more complicated versions of this equation. We have the unknown. It's down in the denominator of a fraction. So to solve this, we actually have to get it out of there. We have to perform a little bit of algebra. We have to multiply both sides of our equation by x. That's going to get it out of the denominator and put it over here on this other side. So we have x times the tangent of 41 degrees is equal to 6.1. Now again, tangent of 41 here is just some number, some sort of a decimal. So in this case, since we have x times this number, to get rid of that number, we just have to divide by it. So we're dividing by the tangent of 41 degrees. That is going to go ahead and cancel out, keeping us with x. And we have to do that on both sides. This is where we get to keeping it exact for as long as possible. Here is the point where we actually have to perform some calculations. We're going to go to our calculator to do this. We're going to do 6.1 divided by tangent of 41. I'm going to go ahead and do this on my calculator. Actually, no. I'm going to clear this and I'm going to do it on Desmos. So let me go ahead and clear, and I'll be able to bring that back in just a moment. So let's go to Desmos and clear everything here. So we have 6.1 divided by, I did a little backslash. You can use the division button. click tangent 41. It is in degrees here, and it's all set up correctly. It has done our calculations for us. Now here, we can decide how accurate we want our information. We can round it to whatever decimal place we want. I'm just going to round it to 1 decimal place. That's just me making a choice here. Our problem was rounded to 1 decimal place before, so I'm going to go ahead and do that in this case. So let's go back to our notes. Let's bring everything back. And we found that this was equal to 7.0. If I can get this right, 7.0. I don't know why I'm on the wrong slide here. There we go, 7.0. That was our solution. AB was equal to 7.0. So I suppose we should write it in terms of AB. AB equals 7.0. Again, the reason I rounded to 1 decimal place was because we were given this in terms of 1 decimal place, but it doesn't really matter. Round to whatever accuracy level you're asked to, or whatever we think would be best here. Anyway, not too complicated, but definitely a new process for you. So let's go ahead and clear this. We're going to try 2 more examples, same idea. All right, solve for the unknown sides of this triangle. We are going to find MP. Oh, keep doing that. We're going to find MP. So that is this side over here. Again, I'm going to call it X, just so that I have a variable to work with. Steps here, again, let's identify the angle that we know. This one is a 20-degree angle. That's what it tells us here. I could use this one down here, right? There's no reason I would use this one. I could figure out that this one was 70 and kind of use this one instead. But why? Let's just use the one we know. Second step, let's label our triangle. We have the hypotenuse down here. We have the opposite side over here. And then we have the adjacent side right here. So hypotenuse, opposite, adjacent, we have everything labeled. Now we need to choose which of the 3 trig functions and trig ratios we're going to be using in order to solve this. So I'm writing out my mnemonic device, SOHCAHTOA. The side that I know is my hypotenuse, and the side that I want to know is my opposite. So opposite and hypotenuse are what we want. That tells us to use sine. Neither of these other ones include both of those sides, right? This one is missing opposite, this one is missing hypotenuse, so it's got to be sine in this case. Great. So we take this and we set up an equation. So sine of our angle equals opposite over hypotenuse. Let's just plug in the numbers. We have sine of 20 degrees equals the opposite, which is x, divided by the hypotenuse, which is 8.7. Okay, this one is a little bit different. Small differences here. Sine instead of tangent. And the big thing is our unknown, the x is actually in the numerator. This makes this process of solving this equation much easier. All I have to do is get rid of this division by 8.7. So all I have to do is actually multiply both sides of my equation by 8.7. Cancels out over here, multiply over here. And that is what I need to put in my calculator. I need to put in 8.7 times sine of 20 degrees, and that's going to equal x. So this is, again, that's what I'm calculating. Let's go to it. All right, so we got 8.7 times sine 20. It's in degrees. We're good to go. Enter. So we have 2.975, whatever. Again, round this to whatever accuracy level we want. If we're going to round this to 1 decimal place, the next number is a 7. So we actually have to round this 9 up to a 10, which makes this actually 3.0 if we round this all the way up to 1 decimal place. So let's go ahead and go back. You can round it wherever you want. If I'm rounding to 1 decimal place, I would get 3.0. There we go. That is our answer. MP equals 3.0 centimeters. Awesome. And we'll do one more. So just so that we can keep doing this, we're going to do one more example before the end. All right. Here we go. We have a triangle. We have YZ is what we want to figure out. YZ is down here. Well, again, we'll call that X. We'll call that our unknown. Yeah. In this case, this is our angle that we know, 38 degrees. I could figure this one out and then use this angle instead, but why? Let's just use the one we know. Now we need to want to label the sides. So our hypotenuse is across from the right angle. That's actually the one we want to figure out in this case. The opposite right here, the adjacent right here. So there we go. In this case, we know the adjacent side and we want to know the hypotenuse. So using our little SOHCAHTOA, you may already know what it is. We're looking for the trig ratio and trig function that uses adjacent and hypotenuse. So we're using cosine. Cosine is adjacent over hypotenuse. So the equation we will set up is cosine of our angle is equal to adjacent over hypotenuse. Okay, our angle in this case is a 38-degree angle. So we have cosine of 38 degrees is equal to the adjacent, which is 12.6, divided by the hypotenuse, which is our unknown X. Again, this is similar to the first one. This is the harder version when we have an X in the denominator. Not a big deal. We want to get it out of there. So to solve this one, we have to multiply both sides by X. That gets it out of this denominator and it moves it over to this side. That gives us X times the cosine of 38 is equal to 12.6. Now remember, this is just a number, some sort of a decimal. To cancel out this multiplication, we just have to divide by that number, by the cosine of 38. Cancels out, and we do it on both sides. And this should be our answer. Whatever we get in this calculation is what X is going to be equal to. We are going to get X equals something here. So we got to go back to Desmos. So let me clear this and go back. I actually forgot what it was. 12.6, okay. 12.6 divided by cosine 38. And there we go, enter. So we got 15.989. Okay, this is a funny one again. If we go to round this to one decimal place, we have an 8 next, so we need to round the 9 up to a 10, which carrying over actually turns this to 16.0 again. Another 0.0. That's funny. I think maybe these problems were intentional that way. So 16.0 is our rounded value. Let's go ahead and bring back our calculations. X is equal to 16.0. So in this case, our side length we are looking for, YZ equals 16 centimeters. There we go. It's not too complicated. These equations are not really that difficult to do. There's a few really important things to keep in mind, along with kind of a pretty set process you can follow. One is making sure you set up your equation in the right way. Right? This the angle measurement always has to go in here with your trig function, and then your trig ratio always needs to include one side that you know and one side that you want to know. And this is the way you'll set up your equation: trig function angle ratio. We kind of end up with two different equations maybe. One of them has the X in the numerator and the top. That's a little bit easier. And the other one has the X in the denominator. It's a little bit harder. There's just like one extra step. And then you're either gonna, solve by doing this, like a number divided by cosine of a number or sine of a number, whatever, or you're gonna end up with a multiplication like we had in the last problem. And this is where we go to the calculator. We try not to go to the calculator until the very end, until we're coming up with our final answer. If we do it too early and round too much, we may lose accuracy that's going to be important to us. So anyway, we'll do this a bunch more. The next section here has us solving more stuff about the triangle. So this isn't going to be the end of it here, but it definitely kind of covers the basics of what we need to do. So homework problems, this is out of the textbook. I uploaded that onto our Google Classroom page. The one you need to turn in is number 38. See you guys later. Have a good rest of your day.